Good morning, everybody, and welcome to our webinar. And today we're going to do some automatic pallet stacker, load pallet stacker, as you can see on my screen. We'll do it step by step with the process flow, and of course later we'll post this video on YouTube so you can review it. Of course, if everything goes well. So 10 o'clock, and my position is to slowly start. If you have any question during presentation, please write them on chat. I will try to answer them during, or if maybe it's something outside of what we're doing right now, I will try to answer it at the end of our webinar. Okay, so let's start. Okay, so we want to do the load stacker. So let's start from the basics. We'll start with some source, with conveyor. Of course, we'll make some connections, and of course, in our model, we need to have pallets. So we'll create the pallet in our flow item bin. So this icon here on the top, go to the pallet. And let's change it to the Euro size pallet, because Flexim is an American software. They have the US pallet, not the Euro pallet. And here you can see that when I shrink it, the planks are in the wrong direction. You can easily change it by going to the more visual and editing the shape factors. So you edit the shape factors, I can rotate it by 180 degree. Oh, sorry, not 180, 90 degrees. So now the planks are positioned correctly. So by editing the shape factor, you are changing how the 3D shape is positioned inside the frame. And the frame is this yellow outline. So if you change the size, you're changing the size of the frame. And with the shape factors, you can move the shape freely inside the frame. So we have our pallet. So now when you have the source, we can change the flow item class to pallet. And I also check arrive at time 0. So I don't have to wait for the first pallet to arrive. So we have the pallet. So in our case, you want to stack those. So let's create this pallet as a pallet with the load. I want to have the full pallet, not the empty pallets. So let's write some logic in the process flow. So for example, whenever pallet pass through this point, through this decision point, I want to create the content of the pallet. So we'll use here the event triggered source. We sample on the decision point. So when something arrives to the decision point, arriving item, let's call it pallet. So whenever it arrives, I want to create some objects, and it's going to be the content of the pallets. So I will create some boxes. From start, let it be 8 boxes, and I want to create those on the pallet. I don't need to do anything else with them later, so I don't need to assign it. And in the end, we'll use the sync to destroy this token. So now when I reset and run it, I will create the content of the pallets. These boxes are shaped, size of these boxes are a little too big to fit on the pallet nicely. So I will go back to the flow item bin, and I will change the size of the box to 59, 39, and let's leave it at 0.3. So with this size, they should fit nicely on the pallet. So you have like 2 even layers. And of course, it's important because if I want to stack those, I need to have an even surface that I can stack this on. you need to look out, you need to be careful. If you use a decision point like this, you have to specify here when the on arrival triggers fires. So if this is the center, if the pallet moves, so if I reset and run this roller, you see that this logic will fire only after the center of the pallet will hit the decision point. Okay. So this is important because sometimes when you reset and run, in this case, not a problem because it starts from the beginning. But if you have, for example, transfer from the side, like here, the center will never reach this decision point. So you have to change the edge to match your layout. In this case, this will be all right. So I have eight boxes on the pallet, and now I can start making the stacker. So let's do it, for example, here. So what I will need to have is some kind of decision point where the stacking will take place. And in our case, in this case, we're going to make the stacker from the elevator. Of course, there are a lot of different ways how you can do it. And I think this little trick with elevator, I think this is the simplest in this case. So let's change its size to be a little more narrow. We'll move it here. Okay. I also maybe make this conveyor a little lower. So the leg, let it be like 0.3 meters. And also change the Z to 0.3. Okay. We have the elevator, and we have to make the gripper from the both sides. Okay. And how can we do it? In this case, let's do it with the animations. So we're going to name it stacker, and we're going to go to the animation options. So click on the stacker, more visuals, and animation, edit. And here you can create the animations for the stacker. So I don't want to see its legs, so I can just click on this eye. So it's not shown. And I'll have to make this grippers. So I will drag and drop 2 cubes, and this is important. I will drag those onto the car. So you can see those cubes, those grippers will be the part of the car. So when the car moves, those 2 objects will also move with this car. Okay. We change the shape to some grippers. Okay. And of course, we'll rotate it. So we can catch the pallet when it arrives here. Okay. So you can see on the model, you already see the elevator, yes, with two grips. So you can say it like this. So what we want to do is we want to slide them onto the pallet so you can take it and lift it up. So this is the, let's say, base position. Maybe make it even, okay? So we'll make it as a base position. I will save it. This is my base position. I will create one animation. Let it be like closing. So I'm closing the grip on the pallet. So I have 2 keyframes. This is the first keyframe, like in the base position. And for example, after let's say 5 seconds, I will move it by Y, let's say for 30 centimeter. So 1.6, 36, and here 0.23. And I will save it. So this is some animation for closing the grip onto the pallet. This is the first animation. Let's create a second animation. But before I will do, I will move the shapes onto the closing position. So then when I create the second animation, let's call it opening, I can start with a keyframe. So the first keyframe of the opening animation is the same as the last keyframe for closing. And then at the 5-second mark, I can go to the base position and create keyframe. So I have the exact movement with the same position for closing and for opening. Okay, so we can go back to our model. And now let's build the logic for a stacker. So we'll start the schedule source. We'll create one token. And we need to have some resource here. And this resource, of course, it's going to be our stacker. And as a reference, we're going to use the elevator. Later, of course, we will make this platform invisible, so it won't be shown. But for now, it's easier for us to sample it, to point to it when we see it. That's why it's still there. We're going to make the acquire. So I'm going to take this resource and let's call it stack. Okay, and what will be the logic here? Yeah? So we have the acquire and we have to wait for something to arrive at this decision point. And in this case, I will name it pallet 1, because I will have pallet 1, the first pallet that I will lift up, and pallet 2, the second pallet, on which I will put the pallet number 1. So this is pallet 1. So I'm waiting for it to get there. When it will be there, I will move this pallet onto the stacker. So I will create a move object here. Move pallet 1 on stacker. So my pallet 1 will be moved on the stacker. And this is what's important. I will preserve its global position. And thanks to it, if I reset and run the model, when the pallet arrives here, you move on the stacker. So right now, it's on the stacker, but it still looks like it's still on the conveyor. So if I run it more, you will see that the next pallet, when it arrives, will just go past it, because this pallet is not right now on the conveyor. It is on the stacker. So I don't want the next pallet. I don't want the next pallet to get here, not before I say so. Yes? So in this case, I will need to create some area with the photo eye, some zone, in which there can only be one pallet. So when pallet arrives at this photo eye, I will use the logic on cover, and I will acquire the area. And the area owner is current out object 1. So the object connected through the A port with my photo eye. So I will make the connection here. So this is the zone from this photo eye up to this photo eye. So right now if I reset run it, in the first palette got here, the second palette will have to wait at this point, at this photo eye, because I didn't free the area or the zone. So it waits here. So now I can do all sorts of manipulation with my palette. Okay, I have the palette in place. It's already on the stacker. The second palette waits, so I can close the grip on the palette and I can lift it up. So let's run the animation. You can have the run animation block here. Let's call it closing. So it's going to be our animation for our stacker. Animation number 1. So you can reference animation by the name or by the rank. So rank 1 means the first animation closing or the second animation opening. So I can just leave here 1. And I can define also here how much time the animation will take place. So if I don't set anything here, it will take 5 seconds because here is 5 seconds. But if I choose use duration off, I can write it whatever time I want. Yeah, so for example, I write here 4 seconds. And I will make the token wait here until the animation is finished. So I don't want to continue my logic, not until I will finish the closing. So let's see how it works. And I'm closing. I've closed the grip, so now I can lift it up. So I can use the travel to location to move the elevator. So in this case, the stacker. I will use the relative. So I will lift it by, for example, 2 meters. So now after the closing, I will lift it by 2 meters. You can see it's not aligning perfectly here. So I can make some corrections by increasing the initial height of an elevator. So now if I reset and run, the gripper fits nicely into the palette. Of course, there's other way to do it, but I think this is the simplest one. So we have the palette. The palette is full. Palette is taken by the stacker, and the palette is lifted up to this position. Okay. So what we need to do now is I need to let the second palette come here, because this area is still occupied. Yeah, this palette acquired this area, and I've never released it. So after lifting up, what I want to do is I want to release this area. So the next palette can move up on this position, so I can lower this palette down. Okay, so I need to release the area. How can I do it? I can check the logic. For example, here on the second photo eye, on uncover, I'll have the logic to release the area. Yeah, this is the logic, because with when the 2 palette will move past this photo eye, I want to release this area, but I want to do it like every second palette because I will release only after stack of 2. So I need to use this code in my process flow so I can release this area when I lift up the palette with the stacker. So I can just copy this code from the pick option start to the pick option end without the headers here. And I can create here the custom code. Let's call it res area and paste this code here. I need to specify the area owner because in this case, area owner was current. Current in this case means me. So the object when this trigger, when this code is, so this is the photo eye, but in the photo eye, current means something completely different because current means the process flow itself. So the area owner, I will specify with the sampler model find. So now if I reset and run it, I move it, the area was released, so the palette can pass. Of course, I still need to stop it somehow because I want to wait for it. So I can lower the palette on it. So after releasing the area, I will create another wait for event, connect this with the decision point on arrival. But in this case, it's going to be palette number 2. So the second palette and the sign. So in this case, I won't move the second onto the stacker because I want the second palette to remain on the conveyor. So I will just stop it. So it's going to be stop the palette 2. So custom code, control, conveyor. You have the stop and resume item logic here. And I will stop the second palette. So now if I reset and run it, leave the first and the second is here. Okay, maybe I write here, like, for example, some 20 seconds. I don't have to wait as much time for the second palette. Okay, so we are here. So now I have to lower this palette onto this one. So I have to calculate how much space is from this point to this point. Okay, because I need to know, in this case, right now we have like the constant number of boxes on the palette, so it's all the same, but later we change it, so I have some random number of layers here. So I will never be sure what is the height that I need to lower myself onto. So after stopping the palette, we will calculate the height. So we use the assign labels to calculate the height of the palette 2. Yes, we have to calculate the height of this palette. So let's call it palette 2 height. And what would be the value here? So I need to get the location, maybe just to show. To calculate the height of the palette, I need to get the location from any box from the last layer. So this will be the location and the size of this box. So in this case, it's going to be token dot palette 2 dot last. So this is the last box onto the palette. So I need to have its location. So location Z, and you can see it didn't color to purple because I need to specify that I want to treat this as an object. So I can have the access for the functions and methods from this class. And this is going to be the class. and the size for Z. So this is the pallet to height. Of course, I could use also here the get location function to get me the location of for this this point. But I think for me this is a little bit simpler, so I can use the base functions. Okay, so this is I know now the pallet to height. So if I reset and run it, I can go to tokens. I know it's 0.73. So I have two boxes. 0.3 this, 0.3 here, and the pallet is 0.13. So 0.3, 0.3, 0.13, 0.73. So this is okay. So now I can use the elevator to travel to this location. So we can use the, again, travel to location. So our stacker. Okay, we'll move relatively to the initial location. So where I am right now, so it's going to be token dot stacker dot location dot Z minus the height of the pallet. So token dot pallet pallet to height. Okay, and we'll see if this works. Reset, save it. We'll see how this works. It won't work as intended, and in the moment we'll see why. You can see it goes higher. Why? Because the result of the equation is with the plus sign, so higher. I want to have it with the minus sign, so I want to go lower. So in this case, I will multiply everything by -1. Okay, so for example, if the location is 3 meters and the pallet height is 1 meter, 3 minus 1 is 2. So go 2 meters higher. But if I create it with -1, go 2 meters lower. So -2. And we see how this works. And the second pallet. And you can see I'm moving myself a little bit too low. Yes. Why is that? Because I have some initial height for the elevator, 0.15. And this is initial height for the stacker. So I need to take this into consideration. So let's put stacker initial height is going to be 0.15. So I need to make the correction here. So plus token dot stacker initial height. So now if I reset and run it, you can see is the exact position. You could also do it without the relative movement, but in this case, the relative movement are a little bit easier, especially when you will have in your model, you have the multiple stackers on multiple different levels. Yeah, because this is like more, a little bit more universal for it. Okay, so I'm in position. Yeah, so I've stacked those, but for now, this pallet is still on a conveyor, and this pallet is on the stacker. Yeah, so if you look at the tree, this is the first pallet. Yes, and the second is still on the stacker. Yeah, so this is the second pallet here. So they look stacked, but they are still on two different objects. So in order for this to work, I need to move the first pallet onto the second pallet. So in this case, again, I will use the move object, move pallet 1 on pallet 2. So I have to move pallet 1, so the one from the stacker, onto the pallet 2. And again, important, you need to check the preserve global position. Because if you check it, the pallet number 1 will remain on the same position. And we position it right on top of pallet 2. So you don't need to do anything else here to position the pallet. So if you reset and run it, now when you see on the model, the pallet has 2 pallets and the boxes. Now we created the, let's say, the tower. We moved it here. So our next task will be to open the grip. Yeah, so to move those 2 grippers. So again, we'll use the run animation for opening. So it is going to be for our stacker, second animation, wait until complete, and provide it 4 seconds. So now when I reset and run it, we see the gripper moves aside. So after I move to the side, I can lower the elevator to the base position. So I can again make the travel to location and move the stacker to the label stacker initial height. So now after opening and putting the part, I'm right when I started. So I'm right there, so I can now release the pallet. So I will use the custom code again to resume pallet 2. So control conveyor, stop and resume item. So you have the pallet number 2, resume item. So if I reset and run it, I will create a stack and move it. But it won't work for the next pallet because I didn't loop it. So now after I complete everything, I can loop it like this. So I'm again waiting for the pallet to arrive to repeat the cycle. Yeah, so let's say in one cycle of this resource, I will always take two pallets. So reset run. Lift it, put it down, grip on positions. And the same. Okay, so we have the base. Let's make it a bit harder because let's say each of my pallet has different number of layers. Okay, so we can change the logic here. And let's say our palette has some random number between 1 to 4 layers. So we write here as a uniform distribution, yeah. Multiply by 4. So you can have 1 times 4 is 4, 2 times 4 is 8, and so on. So now I will have some random number of layers. Because we are using the relative movement, it should work regardless the number of layers on each palette. So you can see our palettes are always, let's say, perfectly stacked. Okay, 4/3, 2/4, 3 or 4/3, multiple different scenarios, and everything here works. Okay, so we have it. It works rather good. What do we change here? In the small GIF you receive in invitation, you will see that we have some pillars here, and of course we don't see the stacker. So we don't see this elevator here. So we can go to more visuals, animations, and just click this eye icon on the car. So now on our model, we don't see the elevator platform. So it seems that only the stacker is moving. You can also see that I create some pillars, and this is rather simple. I've just used some basic shapes. So I've just used the shape, change it to the basic FR, have the pillar shape. Make it small, make it also orange, so I can sample this color. Make it higher. And have it here. In this case, it won't really be exact because the movement here is bigger than the gap here. Yeah, but it only depends on the size of the object and how would you like to do it. Yeah, because you could also create these pillars on the side, or depending on how your stacker is looking. You can also, of course, import the frame of the stacker itself if you have some 3D models available for your disposal. Yeah, so we can also copy it on the other side. Reset run. So you can see it wasn't that hard, yeah. And especially did this webinar because we received a lot of questions how to do it. So let's say it looks nice, it looks good. Yeah, so it represents them accordingly, especially when you have a different number of layers for different palettes. Yeah. So why we use elevator here? So what's the point of this trick? Because let's call it like this, like obviously some kind of trick to make it easier to build this faster. Yeah? Because I need to remove this palette from the conveyor. I need to remove this palette from the conveyor so I can move the next palette on this position. You have used that, try to do it with the translate options. Yeah. So what I mean by translate. So when you have the source, you have the conveyor. You could use trigger, for example, on the station. So try to make the stacker of the station using the on arrival, and here the logic for movement and for translate. So you can lift something over time, for example, 5 seconds or 4. Yeah? So in this case, when you recently run it, when the palette will come here, give me a sec, palette arrival at time 0. So when the pallet will come onto the station, you also lift it. Yeah, but you won't be able to have the pallet on the conveyor underneath it, because this pallet is still remains on the conveyor. So by moving this pallet onto the elevator, I'm removing it from the conveyor. So I'm creating a space, a possibility for the different pallet on the conveyor to move beneath it. And I'm using elevator also because with elevator, I can very easily create the logic for lifting and for lowering. Yeah, because I have the elevator and this is a built-in logic in the elevator. Elevator is created for the lifting something up or lowering something. Yeah, so I can use this elevator. I can use this travel to location. I can easily use the elevator with the acceleration or deceleration, the speed. So I can rather easily make the parameterize it here. And it works very well. You could also, of course, do it with some kinematics here, with the kinematics, but you still need to move it outside the conveyor so you can create the space. And using kinematics on the conveyor can give you some troubles with the movement of the object on the conveyor after doing some custom kinematics to it, and you need to clear all the kinematic subnodes to make it work. So this is rather easy way to do it, rather universal. You can give here a lot of different pallets with different sizes, with different heights, and it looks very nice. Of course, if you don't have that much time and you still need to do it, you could do it in, let's say, very basic way, just by the two conveyors. So two conveyors with the combiner in between. So I'll put a small combiner. When you can like just connect twice the same conveyor, the combiner, and specify to pack it by one. So in the end, you will have, let's say, the same result. So you'll have the two pallets stuck on each other, 20 seconds. With some process time, for example, and 25 seconds or something. So after you have two pallets, sorry, I didn't change the two pallet. So after you have the two pallets, you make them stack, and after 25 seconds, you move them along the conveyor. So you have some possibilities to like represent the same process, but of course with much worse visualization, and it's not the exact the same thing, yeah? Because for example, here you can more easily model different times for different height of the pallets for different number of layers, and this you'll have to write some equations here to compare the height of the previous pallet and so on. Some important things that you may need. Yeah. So in this case, we use here for the initial lift, I specified it's 2 meters. But sometimes you need to. Sometimes you would like to change it. So, and the height here will be different depending on what is the height of the next pallet. So in this case, you need to get the access for the address for the next pallet. So what is the next pallet? And if it happens, so if there is some pallet like this, you could shrink it, for example, like this. And then after moving the object, you can just check the next pallet with the simple sampler. Yeah, because then the pallet here will be the last, the first for this conveyor. Yes. So you could write here that this is going to be next pallet. So you can predict, because you know what is the next pallet. Yes. And the next pallet is going to be from this conveyor first, because you've just removed the first pallet on this conveyor, because this conveyor is as long as, so this conveyor finishes when the stacker is finished. So this is like the also very easy way to check what is the next pallet or what is the height of the next pallet, of course, if it exists. In our case, you never know if you have the next pallet. So you can also check the content of the conveyor, because if the conveyor has no pallets, this will return you the error because there isn't any first object on the conveyor. So you get the error. But if you need this, this is the way how you could do it. And of course, then you need to create a second conveyor to have the fluid movement. Let's make it bigger, 8. And of course, later something, maybe 20 meters, so we can see it better. Reset run. And everything is working. So in the end, as you can see, it wasn't that hard. It's important to know the trick. So think about how do you want to build it before you start building it. So I think this is everything for this subject. So for the automatic load pallet stacker. And what can I say? I'm open for your questions right now. So you can ask the question about the model or maybe about some different flexing matters. And one important thing that I want to tell you now is that we're planning to do the next session on the 19th of May. And our next session, you like touch some cases from the production, because in the previous webinar, we did most logistics, so it's time for some production. And we've received some questions about the rotary tables. So this is our initial plan to make some models for the rotary tables. I don't know how many positions we'll do, we'll see. So the rotary tables are next. And of course, if you have some suggestions, you want to maybe want us to do something, please write email to us, write something on the chat, and we'll see if there will be some enough interest. We'll of course try to build model like this during our webinar sessions. Okay, so thank you for today, and of course I'm open to your questions if you have any. Okay, someone write me private message. Yes, we'll try to. The question with the private message is that what about the shape? Yes, I think we'll provide the shape with some links, because this is the shape I've done like with the SketchUp. So we'll provide this shape in some link under the description of this webinar when it will reach the YouTube. If you have other questions, you can write them on the global chat. Okay, so if there are no more questions, I hope it's good. I hope everything get everything. So everything knows how to build this automatic automatic load pallet stacker. So thank you very much for today, and we'll see each other again at 19th of May, and we'll try to do some rotary tables examples. So thank you very much. And of course, good luck with your modeling. If you have any questions about modeling, please don't hesitate to ask us, write us on our support, to the support@flexing.pl. And goodbye, and thank you again.